Okay. Are we live? We should be. Oh my god. Cool. I'm getting divine intervention and interventions that tell me that we actually are live. Oh my god, 2 concurrent viewers already. Cool. Okay, anyways. So, last time we did this. This is a little bit of an improved version, but it's the Conway Game of Life. I'm actually gonna show it in just black and white for now, and I added a little feature that basically we can recompile the shaders without recompiling the whole thing. And you can see that this like produces some patterns that are completely chaotic based on the rules of the Game of Life. And I missed them, but let me try and get them again. So a person in the chat last time was speaking about how he wanted to see gliders, and sometimes gliders show up here. They were there it is, one little glider, and now it fused with something else. But anyways, today we need to turn this into a convolutional cellular automaton, which will be closer to Lenia. I say we begin with a little drawing. I will open Krita and then explain what we are trying to do. Sure. Okay. Okay. That's not bad, I think. Oh, maybe like this. Here we go. Okay, so what we're trying to do, I'm gonna close this, is basically implement one layer of a convolutional neural net and then have it just evolve through time. So what we will have is basically this kernel that goes through the image, and for now we're just gonna divide it into this square, right? And then this will be like some matrix of numbers, right? So we go through with that kernel through the whole image. I am going to reduce the size of this a little bit. Maybe that's too much. Something like this. Yes, okay. So now I kind of want to do... come on. Why is this not working the way I want it to work? I don't know. Lines don't work. Ba-bam. Now I'm drawing straight lines. Okay, so we want to basically get these, multiply the pixel value by the value in the kernel, and then pass it through some function. We're probably gonna do a sigmoid function, and then like write it to the output of the screen. Yep. Okay. I think writing it in the shaders will be easier and simpler. But first, I thought it would be nice to just go super fast through the little improvements I made off stream. So the vertex shader is still hard-coded because, well, you know, I just want to work with the cellular automaton, so I didn't do anything. But I added this, which is basically this monstrous match expression that gets the virtual key code, and if it's the letter C, it will just recompile the program and then reset the time, and that results into what you saw. Like if I click C, the thing just restarts. Okay, and then if some changes are made to the fragment shader, they will just like pop up. So that's great. That is perfect. And it also says like which keys were pressed on top of the thing. That was for debugging purposes, but I didn't bother to remove. All of this is on Git, so you can always check code there if you have questions. That was very funny, divine intervention. We're bringing back the skit stream back. So this was the first one, for those unaware of the rich history of almost a month of me doing streams on YouTube. And yeah, so for the unenlightened in chat, the divine intervention just mentioned that she's gonna still steal all of the work we've done on this stream together, me and all of my other voices. Anyways, let's actually do. Come on now. Yeah, crazy. Anyways, so first, up until now, we were doing this thing where we're just checking rules. Like, for example, if we have 3 neighbors that are alive, we're gonna just become alive, and otherwise we're gonna decay, right? That is one of the rules of the game of life. And then the other one is, if we're in a life cell, we can have 2 neighbors and we can still stay alive. That was the idea of the whole thing. So now we kind of want to get rid of this, and I'm gonna write this as something like Conway frag, so we can have a snapshot of where we are, and I can just work in this file. Yeah, so we don't need this part. We just need to produce this D, which will be some function, which I'm just gonna call activation for now. Right, like this. And we probably want to pass something like float. Let's call it x. Yeah, we can do x minus 0.5 squared or something like that. You know, to just try how it's gonna work. Maybe if I don't come up with some function plus kernel that actually produce some chaotic movement, maybe you can see what the kernel and the activation function of Lenia is. But yeah, we first want to define the kernel. How are we going to do that? Let's see. So we're working in version 140, which means that, you know, we will have 3x3 matrices, but I kind of want to scale that up. Maybe if we have like a bigger neighborhood. But yeah, let's actually start with something like yeah, matrix 3, and then go for kernel. I don't know if that's how you okay, it's with a K. Exactly. So mat 3, and then here it's column wise. So let's do something. What is a Gaussian kernel? I don't exactly know. Yeah, but it's probably something like 2.5, 0.5, 2.5. That is the first column. And then we have something like 0.5, 1, 0.5. I mean, this is not a probability function, but it's probably a good estimate for something like that. We can even probably like normalize all these vectors, even though if we normalize them column-wise, it's not going to be whatever. Maybe like we can just divide by the determinant. But yeah, that should be a 3x3 matrix. We have 9 values, and that should be fine. So now, instead of checking whether or not we're on the correct thing or correct level, what we want is to just discount, replace it by sum, which will start from 0. And then what we want to add is basically, why are we flooring this? Oh yeah, it's because we were counting basically, is that cell alive or not? But now everything is in between 0 and 1, or every cell could be in between 0 or 1. And then we want to just multiply this by the kernel of ij. Something like this. Even though, it will probably be something like this. Plus 1. And I hope this works. Plus 1. And we want to basically just do the activation function on the sum. Okay, so this should be like the whole idea. So we have the vector 4, but we care only about basically its vector, or not its vector, but its x value, because now we're just going to be working on in black and white for you know, to begin with, and then maybe like this could be a vector 3, so we can have a sum per channel. And then this activation could be actually like a vector 3 to vector 3. And then we can have something working inside like 3 color spaces simultaneously. But let's see if this will actually work. It provides some tracebacks. Let's see what it says. So there was a compilation error. D was undeclared. Fair enough. This should be float D. Again, state was undeclared. Right, fair enough. We just want to remove this. And let's recompile. Again, it does not work. Let's see. Count was undeclared. Because we renamed it to sum. Great. This is how to write shaders, kids. Oh my god! Something happens. Go figure. Yeah, I mean, fair enough. Let's try to... I know, right? I know. But it kind of does make sense that, like, just everything goes to infinity. Because the activation function just squares everything, and sum will most probably be more than this. But maybe if we just make it like very hard to be in the initial noise, like, yeah, if you can see, like, it takes longer. So I think just the kernel parameter and the activation function are not quite right. So let's okay, I'm going to open Firefox on this side. I'm guessing one function could be very beneficial for our automaton, and this is this function, which is a sigmoid. It's very cool, I know. Don't worry about it. So what we can do is basically we can create a sigmoid, and that will be our activation function, and then no matter what value we pass, whether above 0 or below 0, will then be passed through the sigmoid function. Now, we probably want something that will result in negative values sometimes, right? So maybe can we use this as yeah, Westworld is cool. I did not watch the last like 5 minutes of season 1, or like I was watching a season 1, and then for unknown reasons my video player crashed, and then I think I have a better ending in my head than the actual season. Thank you, voices in my head. I should probably stop doing that. And for those automated algorithms that will assess my mental state in the future, I'm talking to my girlfriend and not to voices in my head. But anyways, so something like this will probably actually, look at that, different things are happening. Oh, can you see this? Like, there's actually movement in there. It's just in the yeah, it's in the predominantly like super blown out, and probably because of video compression is undetectable. But yeah, I'm gonna close this. So let's actually implement sigmoid. And why am I doing the kernel like this? It's basically, I want to have some negative values, so I can be on this side of the sigmoid as well. That is the idea. That is the idea. And then the coefficients from the previous frame become just the coefficients for the kernel. So let's actually implement this. So this will be 1 over 1 plus exponential of minus x. I don't know if you caught what I just said, but it is not that hard to get it. It's just yeah, we exponentiate minus x, and then we get the sigmoid. So now I am expecting something that's that's true. That's true. Okay, that low-key is cool, super cool. Like, look at that. That just generated some pattern. I don't know why it's stable, to be honest. I have no idea. Especially because it's... Damn. I do like that a lot. I do like that a lot. I wish that was in the thumbnail. There is no movement though. Let's try and play with the kernel a little bit. See what we can do with it. So for example, if I change it asymmetrically, so now it's kind of like an ellipse kernel, if that makes sense. I should probably visualize it in some way. Oh my god, that's probably causing epilepsy to people. That was extremely unstable. I don't know why that happens. Or even if this is something that should happen. Let's think about this. So, actually, I cannot spot a mistake in the code. If somebody in chat has an idea from where exactly that comes from, that would be great. Thing is that that's not the same pattern as previously. So if I rerun this, yeah, can you see this? This generates different patterns based on that noise. So let's say we were using some hash noise before. If we change the hash noise, the pattern at the end changes as well. Isn't that super cool? I really don't know why it stays stable. I do want it to be more of a fluid thing. Let's see. let's see Lenia and how their kernel works. Yeah, I mean, it's yeah, I don't have that much time, so maybe a Wikipedia page is better. Yeah, so they have the same. Do they have the same neighborhood? Oh no, they're using a bigger neighborhood. So okay, we're actually approaching it in a different way. Yeah, makes sense. Because this autonomous pattern in Lenia is too big to be stable in our situation. And their kernel is basically drawn by some function. That is... Yeah, I don't think we should implement Lenia per se. Because yeah, that looks incredible though. That indeed looks incredible. But I first want to see like what a small kernel can do, because basically what the difference is here is basically if you can see, like that is probably a 7x7 kernel. That makes it way more computationally expensive, and obviously we only have that little triangle, that little square that is passing through the whole thing. Okay, that is great that we actually found something that produces like super cool patterns, but I also want something that produces, well, you know, something that is evolving through time. Again, I have no idea how this is stable, but that's the beauty of streaming. I could be making some massive mistake, but who cares? It's graphics. So let's actually edit this somehow. So our kernel looks like this, where this is the first column, this is the second one. Ah, that is a great idea. That is a great idea. I think I would pull a reverse one on you and now steal your idea and make $1 million. Actually, the voices in my head cannot sue me because they're not real. Anyways, maybe they will. Maybe they will. So let's try and populate a kernel based on something. So I don't know. How can we do this? Maybe we can basically get a circle, or like a distance to a circle, or a Gaussian filter. Let's see. I'm gonna pop this to the side because I don't want my search history to come up. So let's search for a 3x3 Gaussian filter. Ah, okay, I understand. That does not add up to 1, or does it? So this is the thing that I saw, which is just a Gaussian filter, right? What we can do is basically add something that corresponds to this, and this is a probability function, so it should stay like mostly in the middle of the sigmoid, because it will be like the sum will be from here roughly to here, right? Maybe it will decay out, maybe it won't. We will see. So, actually, this is 1, this is 1/2, and this is 1/4. So if we just multiply this by 0.5, now we have this. We have the Gaussian filter. Wasn't that cool? We unknowingly implemented a Gaussian filter. Wow. Okay, I did not expect that. I did not expect that to happen. I did not expect that. But maybe it's because of this, right? It makes sense. It will just be 1 all of the time. Let's do this, where now everything that is in between 0 and 1 will be kind of the target of the sigmoid, and everything disappears. That is very sad. That is very sad. How can we, what function can we try for, what function can we try for the activation? Let's actually try and just Gaussian blur everything. So that means like no activation function whatsoever. Okay, that kind of looks cool, right? That kind of looks cool. That's Gaussian blur. But what can we do to this thing to make it interesting? So this basically is dispersing Okay, let's do something like this. This will be 0. This will be 0. Right, that is kind of strange. Let's target an FPS that is lower, like 2. What? Blocking waiting for file lock to cache. That is going way too fast. Way too fast. So 10 frames per second is fine for a little animation. We're doing the activation, but we're not doing, we don't have anything that is actually negative. So let's actually do something like this, where the sides are negative. Maybe we get something more interesting out of it. No. So if we have more suggestions, that would be great. But in the meantime, I'm just gonna open yet another Wikipedia page. Okay, so here we are at the convolutional, no, this is just a cellular automaton. So, let's see. Right, physics, sure. Generative art and music. Okay. Okay. Brian's brain. Right. Yeah, these ones we've seen. Damn. That's sad. I have no idea what activation function actually to use aside from sigmoid. We can probably do something that is we could probably do something like clamp I'm gonna open Desmos in a bit so we can try out some stuff there, but first that looks cool. That looks cool. So that fades away in this anisotropic kind of way. That's cool. We can even can we just make it fade in some other way? Cool, but I don't think that's that impressive. Maybe break some symmetry instead of creating symmetry. Right, it's like fading effects at this point, but we don't want it to be just fading. So let's remove this times 25. And now we have this kind of a different stable pattern which just forms channels. Isn't that kind of strange? It is kind of strange, yeah. Let's see. Oh, you can even see why those channels get formed in this kind of a sandy pattern way. Yeah, this now is a different noise thing. Looks more like rocks, and it's kind of not symmetrical, which is interesting. Let's see what happens if we make this minus and everything else around will just be a normal Gaussian interpolation. Okay, that does not work that well, unfortunately. Maybe if we multiply by 0.5, okay, that is something straight out of a hypnosis clip. Like, I don't know. It's kind of cool. Okay, I think that was a better function. So let's try and cook up some stuff that is just cool to look at. So Desmos, I showed my search history, but you know, who cares? Who cares? Here we are. Keys. So let me try and first visualize what we did in terms of what functions we used. Why is Desmos so cool? Is because it's cool, ladies and gentlemen. That's why. So we did this thing. What was it? F of x equals to 2x, something like that. Yeah. And then we clamped it here. So it will be something like max, no, actually min between this and 0. 1, I meant. So this is the function we are using now, where everything that is outside of the range -1 to 1 gets mapped to gets mapped to 1, and everything else is just this parabola shape. That's why we're able to produce these like kind of oscillating visuals, if that makes sense. It kind of has this like old-timey dithering effect, which is kind of cool. Maybe we can even like make it into a certain direction. Like now I'm expecting it's kind of gonna like pulsate laterally. Right, I forgot that it's a completely different direction, but let's see. So if we're getting the -1s from elsewhere, can we get it to stay in some way? Yeah, this is also a very interesting pattern, because now like there's movement in this direction, so like everything kind of moves predominantly in one direction, and they cancel each other out otherwise. It's an interesting concept, this automaton thing. Okay, anyways, so let's try and come up with different functions that make sense. So one thing that needs to be there is basically we need to map from any number back to 0, 1. That is the thing. We kind of need to have that. And also, we probably want to have pixels on the screen and not just blow the whole screen white or have everything be 0. That also is something to keep in mind. So in this way, basically, as long as we have stuff that is in these regions, it should be fine. Let's try and actually do 0.5 here. Okay. Okay, maybe we can do the absolute value of x, 0.5. That could be interesting. We can even vary this to time. So let's say we just have the absolute value of x, and then let's pass u time through a sine function, and then add 2. Does that make sense? Yeah, probably adding 1 makes more sense, and then doing something like 0.5 here. Yeah. Yeah, and you can see how the activation function actually has a extremely profound and very defining effect of how the finished thing looks. Let's revert back to the good kernel. I think this was the nice one. Okay, I did not expect that to happen. Of course, because we needed to divide this kernel back. Okay, maybe even more divisions, apparently. That is kind of funny. That is kind of funny. Now, because every value on the screen is the same, it's just the equivalent of doing the operation on a single pixel. Okay, maybe Gaussian filters are kind of bad. Let's try something more extreme. which is just ignoring most of them. And just taking these three. What did I do? Float constant. Unexpected float constant. Where? Line 18. Expecting a bracket close? What? Are the zeros the problem? Wait, are the zeros the problem? Do I need to do this? OpenGL syntax never ceases to amaze me, but it's something that I missed. Oh, I just added a point here. I kind of like that pattern. So it basically morphs from yeah, the function here basically morphs from 0.5 to 1.5, and we have just why doesn't okay, 1.5, and then oh, come on, no step, right? So it just does this, where based on where we are at, it just maps it to a different thing, right? That is interesting and all, but also I kind of want to try something that will kind of evolve some other picture. Like for now, we have basically been working with this. So right now we're just generating this hash noise that looks like this. It looks kind of cool, I'm not gonna lie. I very much like it, but also it's kind of so basically this is our initial condition for the automaton to like go through with, right? But this is too chaotic, and the thing is, like, yeah, because we want to actually generate the entropy so we can see the automaton work. But I kind of want to have something that's I don't know, like circles going like, I don't know, circles going in a circle or something like that, or a circle made of circles, so we can see how that works. So let's actually construct D in a way where we can have some sensible default. If I can if I can actually get like a click of the mouse from Gliom, maybe we can implement actually drawing on the screen. That could be interesting. Are the concurrent viewers interested in me maybe spending 30 minutes to implement drawing on the screen? Or do we want to just focus on making some nice procedural default, which will be like, I don't know, a circle made of circles? Which would you prefer? I wish I knew how to make a poll. Oh my god, I know how to make a poll. That's sick. Okay, would you like drawing on the screen Or all right, fellas. Bam. I've started the poll. Please answer. Okay, that is an overwhelming yes. Complete another yes. I wonder why. But yeah, I mean, that's how democracy works. So let's actually switch back to Rust then. We probably have something like a window event that is mouse hover or something like that. But let's see what all of these window events, like what those window events actually could be. So going to that, we have resized, moved, closed, dropped file, wow, hovered file. What? Yo, that has like some cool stuff. Like we can drag and drop files into our window and make it do something with that. That's cool. That's cool. I have no idea how that is like, you know, interesting, but it's whatever. So cursor moved. Cursor was moved on the window. We have the physical position of the cursor. That is fine. We have cursor entered and cursor left. We don't care about that. We probably care about mouse input. Okay, we actually don't want to do that. Touchpad pressure, axis motion, touch. That is great. I love the fact that it just says touch. Like that's the event. Touch, and it just contains the touch. That is the thing. I guess you don't need more. Oh, interesting. So we have this, which is us receiving the event of cursor moved, right? But also, you know, like we want to wait, deprecated modifier state, deprecated in favor of window event modifier changed. How would we approach this though? Because this is two different events. So let me try to explain what I'm thinking. So here, what we do is basically we get an event from the event loop, right? We get an event from the event loop, and how we process this event, we basically see if it's closed, just kill the graphic contents. That's fine. And then the way we process keyboard events is we do this insane match expression, which gets the virtual key code, and that kind of works, right? Now for the mouse event, we want to process two events simultaneously. So we want to have so we want to basically have the fact that the mouse was clicked and what is the position on of the mouse on the window, if that makes sense. So if we let me just spawn the window for the sake of illustration, but we're moving our mouse. I probably should have stopped this, but we're moving our mouse, right? And we want to basically get the mouse position, but also we want to see whether or not the button was clicked. That is important. And also we want to see whether or not we're holding the button down. I guess we can just process the events anyhow, and then pass it as uniforms here. Like basically have something like, let's actually define them. U mouse position, like this. And this will be a pair of, let's say, 0, 0 for now. Actually, it probably will be int. Yeah, it probably will be int, because this physical size, this thing, oh, this is actually float 32. Okay, these will be floats. These will be floats. That's fine. And then we also probably want the uniform of mouse hold, which will just be false. This will be a boolean. And then we can do the logic in the shader about like how to actually draw in the shader itself, if that makes sense. Okay, let's try and populate some uniforms with that. So here, let's just do let mute mouse pos. This will be float 32, float 32. And let's just pass 0, 0 for now. Right. We wanna create one of these gluten event moves destroyed. Isn't that cool that I can just like scroll to this list and then just get the thing I want? So this will be this thing. We only care about the position, so I don't care about device ID, I don't care about anything else. Modifier state, I don't really care about. Right, we will just do this, I think. Ellipses and raster, just 2 dots. Right, it will be this thing. Let me just add a to-do macro so this knows. So now we basically have the position. Why is this complaining? Why are you complaining? Fat arrow, yes. Okay. So now we have the position basically set. We want to unpack this physical position somehow. I think I had a helper function before that just unpacked that. Oh, that's physical size. That is so sad. Shit. Okay. Yeah, let's think about that. Can I just have a generic that just does that? It would probably be simpler to just copy this and then be like unpack physical position like this. Right, because this is actually... Yeah, this is actually extremely interesting in the way of, well, this is much more involved. So the physical size was U32 because it could be just positive numbers that are integers, like we cannot have half pixels, but our mouse cursor can actually be in between 2 pixels, and it's actually higher precision even. Yeah, completely never thought about that. I think it's better to just have them as F32s, just because it will make working with uniforms easier. But yeah. So physical size, right? Let's actually rename this position. Bam. This will be position, and this will be physical. You guessed it, position. And this will even add this. I also love the imports of Rust. The fact that you can have this thing, like basically say I want to import from this, and then from these two, but from the previous you can like you can upload more. Like that is kind of like an import system that I really enjoy. Do you get what I'm talking about? It's something that I appreciate about the language design. But yeah, so position doesn't make sense, right? Let's see what attributes it has. X and Y. Perfect, perfect. So X and Y. Thank you for the hearts in chat. Very much appreciated. Yeah, so we're here at position. We want to get unpack physical position, and we pass position here. Right, let's think about this again. This will actually be, the way we passed this was U resolution or whatever. Yeah, so the way this is passed is as an array. So it becomes a vector on the other side, or a vector 2. So I think it will be the best to just yeah, I think it will be the best to just have something like mutable mouse position, and this will be actually physical position. Can we have something that's uninitialized in Rust? I don't know. I don't know. I mean, at the end of the day, that's not something that we should care about at the moment. It's hard for me to explain what I just heard in my head. Anyways, doesn't matter. It actually does matter. It matters a lot. What was that? What was that? No, I said it matters. Wait, what is the... How are you flinging that emoji in chat? Is that a crying emoji? How are you doing that? Yeah, we're celebrating now. Hundreds. That is the best YouTube feature. You know, after the ad block blocking, which you can block. That's a great sentence. Yeah, so let's unpack this here. Unpack physical position, and this will be position. Great stuff. We just need to reference it. Okay. Good. We just add here mouse pulse. Next thing on the agenda will be to gauge whether or not we actually are holding down the mouse or we're not. That's it. So how do we do that? We want to look into another event again. Very sad. Yeah, we can see exactly what we have here. It will be this. It will be the mouse input. Right. We have the device ID, the state, and the button. So let's see. So we don't care about the device ID. And we don't care about the modifiers. This is something we just don't care about. And that is the whole thing. And let's add the to-do macro, so we tell the compiler that we're doing this and that it should not bother us at the moment. Right, why is this complaining again? It's because it's Rust. Oh, right, because we want to tell the match expression that we don't care here, we just add ellipses, which tells it everything else. Just do not bind to a variable. We don't need it. Right. Let's go to mouse input and see what this actually does. Element state. Pressed or released. That is cool. That is cool. Let's think about it a little bit. Yeah, I think what we can do is we see whether or not the button, this mouse button, is I don't know if I can do it in the match expression, but it will be nice if we can check whether or not it's just a left mouse button. And then that will say, okay, now I'm holding this button. Let's see. It will be this thing, right? Button is equal to mouse button. Why is that not working? Work, please. Yeah, it just doesn't know this one. Can we even like do that in a Rust expression? I expected a comma. Mouse button. So what is this type and how can we import this type exactly? Yeah, it's this mouse button left thing. So it's winit event mouse button. Can we just do gluten event mouse button dot left? Maybe we can, and then that will be great. Also, for some reason, my computer is chugging a little bit, but that is... why does that have all these problems? We can just have it as the type of left here, like this. Okay, I think, believe it or not, that works. That just says if the button is this type, then basically do something with the match expression, right? And we probably want to do something like mouse hold, which will be, okay, let's call it mouse held. And this will be Boolean, and the initial value will be false. Then here we'll just do mouse held how would we do that in a cool way? Let's do a match expression on the state. Right, so one thing is basically right, so this will be gluten event element state pressed will correspond to so if we press, that means we're holding it down, so this will correspond to true, and if it's release, this will correspond to false. And now we basically have our little state machine, I think. Why is that not oh, okay, released, and this is exhaustive. Yes, okay, so this is never read. We're gonna fix that now. Ah, come on. Mouse held. Would you look at that? So if I did everything correctly, I kind of want to debug this, so let's try it. So I'm just gonna print. Come on. Come on. Alright. I'm just gonna print mouse position and then see if I'm holding down the mouse. And if we're doing everything correctly before we go and do the logic in the shader of like actually how we're gonna draw a circle or something like that. Okay. Are you ready, kids? Aye, aye, Captain. Yay. Good shit. So, let's do something which will be... Yes, okay. I'm not entirely sure whether or not this will be printed without me debugging it, so this will be the position, and held will be just a thing. Here we just want to pass mouse pause. This was moved already, no? It was not moved. Wow, that is actually, I cannot believe that that actually doesn't lint. That is problematic. I would have expected this to error out. The holding down doesn't seem to work. I'm gonna reduce this window a little, by the way, but... Okay, so what I want you to notice is basically everything works. Okay, the holding does not really do its job, but the mouse is actually... Yeah, the mouse seems to be working. The other thing doesn't work. Okay, let's close this. Great. Was there a true anywhere? Oh. It's interesting that this just does not like the fact that some the this should be outside of the event loop. That's why it doesn't work. Right, we were just initializing this variable that was then just false all of the time. You get why? Because like we were starting from here, and then only when it's pressed, then the true came up. Okay, I am going to try this again. Please compile. Also, yeah, for some reason everything is extremely sluggish, but I think that's just video encoding. Okay, so we're back at it again. If we hold down, see, we're holding down. Cool. Okay, 0 concurrent viewers. We're breaking records here. Okay, I guess the dashboard in Creator Studio is broken. Yeah, extremely broken. But that is fine. That is true. That is true. What the divine force said is that there are 100 billion gazillion viewers on the stream at the moment. I agree. I completely agree. I've never heard more true of a statement. Anyways. Anyways, let's actually try and make this draw stuff. So currently, what we have will be to first read the uniforms, which will be a mouse pause. Did I call it mouse pause or did I call it mouse? I don't remember. Mouse pause. Yes. Okay. And the other one will just be a Boolean number. That will be mouse hold. Right, that is great. So, what do we want to do in that scenario? So we want to basically let's just first do this, right? Or actually even better, just do this, right? This if you mouse hold, it's true, that means we're holding the mouse down. What we want to do is to compute mouse UVs. Yeah, we want to compute the mouse UVs. This will be mouse pause, right? And then yep, and then mouse grid UVs will be this. Actually, I think mouse UVs is fine. And then let's first try and see what we can get. So mouse UV, yeah, let's try like length. Fuck, I misspelled. They should have just called it len. Nobody knows how to spell that word. Right. This is uniform. That's what the U under dash means. So this does not. Wow. Okay. Okay. That is good to see. Can I kill this? Great. I don't want it to print that much debug information, so I'm just gonna kill this. So here we're doing something that is not correct. We want to basically subtract the UVs from the mouse. Why is it compiling so slow all of a sudden? Please compile. Oh wow. That is extremely slow. Wow. Incredible. I don't know why it's so sluggish. Maybe it's because of the FPS. Let's try and bring this FPS up then. Let's try and target 60. Yeah, and let's recompile. No, it still has that same problem. It's just sluggish for some reason. Let me see off screen if there's something that's just hitting my performance a lot. All right. Let me just do this for 2 seconds. I had some stuff running in the background. Maybe if I remove that, it will be less sluggish. Okay, we're back on the streaming track. I don't know if that's the if that fixed it. It doesn't seem to. Yeah, look at that. Why is it so slow? It's just incredibly slow. Maybe it's because of Emacs or something? Let's try and run it from a terminal. Also, this for some reason like completely does not want to close. Which, fair enough, but also... Okay, let's try and run it through here. Cargo run. Right, we need to go to the src directory because that's where the shaders are. Okay, so now we're running it through here. No, it still has that same problem. It still has the same problem. Why is that the case? Also, it's kind of going in the complete opposite direction, which is a little concerning. Let's see if we did something that is just bad. So here we're creating this thing. I doubt that is the problem. But let's get it outside. Let's try and target something that's lower FPS, so it makes more. Huh. I mean, that's probably like just the previous texture being previous texture. Yeah, maybe we can time something, but I don't know. I don't know why this is so slow. It's supposed to be fast. It's Rust, but it is slow. So that's very sad. Very sad. Why doesn't this want to close itself? Does the lack of commas make a difference here? No. It's still the same problem. It's just slowly processing events. It's not even capturing them in the proper way. That is a little sad. That is a little sad. I wonder what exactly from here is the problem. Let's try and autofill this so we see yeah, okay. So we don't care about the window ID, obviously. Right. And then we yeah, basically we match on this event. We do all of that. Yeah, okay. I think it will still be useful if we can draw, even though we won't be able to, even though it won't be real time. It'll be kind of like delayed. But I don't know if that's because of the stream or that's because just the implementation is bad. Right. This was rest. Oh, wow, that is so slow. If anybody has a suggestion why this is so slow, this will be extremely welcome. I cannot close this window. It's processing that many events. That's just crazy. What did I do? I don't know. If we comment these out, if we do a little bit of thing like this, wow, why did that die? Float 2? Yeah, float vector 2. So, mismatch type, name this, and yeah, why is this not working then? Mm-hmm. Yeah, mouse position will be float vector 2. This is a float vector 2 with this initial value. I'm not updating it with the position, so we'll just stay as 0. On a uniform type mismatch, U mouse position. Yeah. Did not do that? Did I not do that or something? It's an array of this. I guess I can just do like double zeros like these. I don't know. Please don't error out for no reason. As it was the same thing. So float vector 2. U mouse position. Unwrap on what? Uniform type mismatch. Okay. Interesting. Let me just uncomment this, or like comment out this. And this will just be vector 2 0. I don't know why this is handled as a mismatch, but this should be fast. Yeah, now process the event, no problem. Okay, maybe I'll do like what every great coder does and ask ChatGPT on the side how to solve this great issue while I'm coding something else, which will be the actual brushstroke, because we want to create that. I don't need to get started with that. Thank you very much. Okay. So, can I hide this? Yes. All right. So it's here. It's GPT. Oh my god. Wow. They've updated something. So that will be interesting. Ah, look at that. We can upload files and everything. Ah. Wait. I'm getting an idea. let's upload the files that we just had, this one and this one. So we upload them, right? And then I want to say, I want to monitor mouse movements, but the code that is commented out in the match expression is too slow. How would you better implement this using gluten unit events? Okay, we just let that do its thing. Oh, I don't believe that's true. Like, I don't believe that actually solves the issue, but it would be sick if it actually does. So let's try it. So it's telling us to look at device events instead of window events, which it does make sense. I am guessing. So let's see. We want to get the events, right? Event. Let's see. Right, device event, and then events. Okay. Imagine if that actually solves it. Like, I will be so surprised to do this. So let's see. This will be event. Oh. Right. What do we have here? Right. Let's see what device event actually is. So it has a device ID and a device event. Are they removed? Delta. Change in position. Mouse motion. Represents raw hardware events that are not associated with any particular window. Game controls many action buttons such as mouse movement can produce both device and Windows events. I don't know. I don't know about that because that's actually like what the delta provides. Oh, can I just change the control flow scheme? That's the other thing that GPT suggested. Where did I? Yeah, so we can just dereference this. Alright, don't know. Will this be better? I don't know. I kind of don't want to deal with the physical window events. Control flow from event loop. So that will be Okay, it will be like this, like this. We probably want to do event loop. That little thing actually knows a lot about Glium, which is interesting, because I don't think this is the like the most well adopted graphics library. Maybe the most well adopted. Oh, that is gluten. Okay, gluten. I actually will employ more of the block tricks for importing stuff. Why does it add the other bracket now? Wait, what? Okay, so now we have event loop and we have the control flow. Done. Okay, let's try. So that is okay. Let's actually do what to do here. I would probably want to this hit the to do. Yes. Okay. I should have probably foreseen that. But basically, like, we had a device event, which was probably, I don't know, some camera or something. Okay, there is an unused import. That still seems to have a problem with that. Yeah. You've mentioned that the code is slow, which is often due to excessive processing within the event loop. This cause you use the pull strategy. Oh my god. Can you like not do this? Stop. Stop. If there's no event allowing continuous rendering computation, you only need to update events. Consider using control flow wait instead. If you only need updates on events, consider using control flow wait. All right. I think there's no reason to just continuously bash my head into this. I really wish this actually didn't block the whole thing. But yeah. Control flow. Right, there it is. Control flow. When the current loop iteration finishes, immediately begin a new iteration regardless of whether or not. Wait until. Right, the pull strategy. redraw or update a logic. Event and new events calls. Start this. I actually don't know what this thing means, so I'm just gonna delete it. See if stuff runs faster without it. Obviously, that was the template that we copied back during the first stream. That is still incredibly slow. I'm just gonna stop these events, and even though the massive pool that is untrue. I think a lot of people that claim that they don't use GPT actually do. How about that? And it's nice, especially for you know, for stuff that is libraries that I have no idea like exactly how everything works. I do not want to respond to the voice in my head, but but yes, I would consider no. It's a peculiarly schizophrenic stream. Yet again. Writing Rust code and talking to myself. What a great part-time. No, don't go. No, don't go. Don't go. Apparently there were people actually dropping by to see the stream. Cool stuff. Cool stuff. But yeah, okay. I have no idea why this actually works the way it does. We probably can just not wait for the control flow to do some stupid stuff. Like this, I think we can just... Yeah, what if we delete all of this target FPS stuff? I think this just makes it worse. Because I think we can handle only one event per redraw. Which makes even less sense because this is not happening in the event loop. So we're redrawing everything. That is a very bad template. Now that I actually read semantically what everything means, this is actually a very not a great way to do anything. So close, dropping a file, hovering, focus, keyboard input, IME, modifiers changed, cursor fixed, mouse input, touch scaled, theme changed, and occluded. Okay. So, how will we draw the event loop? Like from how I used to write these in C, it was basically we'll exhaust all of the events, and then after that we'll have some target FPS that then redraws the scene. Like the thing is, we had something that would block until there's no nothing in the event queue. So let's try that. Let's see actually. So the event loop is coming from where exactly? Where did we define this? Yes, event loop. Okay, we want to have this, which we are passing the event in the control flow, and basically we want to process the events and then have something happen not every time we process an event, but rather every time the event queue is empty. So how would we do this? How would we do this? I would say, yeah, of course. Okay, see you, Divine Force. Okay, going back to the thing. So there's a control flow, which is the pooling thing, right? Now we're running this whole event loop, which just processes events. I think it's time to dig through Glium examples. Okay, okay. Actually, we were already grilled for using GPT. Might as well use it again. So let's see. How would you structure main RS in order to process all events and redraw redraw the scene only when the event queue is empty. So yeah, so we're building the event loop within the control flow, and we match the events. Sure. Redraw request. Interesting. I'm pretty sure that is not. That does not. Ah, okay. Interesting. So we have this event. It's no window event, it's just event. Very strange. Okay, so this is a new event, window event. Right, user event. emitted when an event sent from this. Okay. Suspended. Resumed. Main events. Okay. This is useful place to put your code that should be run after all stage changing events have been handled. Okay. Main events cleared. Sure enough. So this is the keyboard input. I'm going to... Nah. Yeah, okay. So here we'll just do gluten event 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 main events cleared, and then we can just add that code in here. Right, this should now basically run with no massive problems. Right, we want to basically this. Is there something that we're missing? I don't think there is, and let's try. Yeah, that does not need to be this, and yada yada. Hell yeah, we can actually redraw our scene, and we don't need all these events to actually do their thing. So let's see. Creating the event loop. Okay, this is responsive now. So let's go back to this. Wait, why doesn't this incredible thing do anything? So yeah, here we have this. Right, I uncommented this, I forgot. And this will be mouse position, or like, yeah, U mouse position. That is great. And now yeah, for some reason it's in the opposite way. If we go back to the Rust code, this mouse input, not this, the cursor moved. Yes. So the top left corner of the window, because relative to the top left corner of the window, the top left, the top left. Why would it be the top left corner? Relative to the top left. Because the range of data is limited by the display area and might have been transformed by the OS. All right, I mean, I guess we can just Yeah, so this times vector 2, we want to flip the second chord. So this will be 1 times -1. And we can stop this. Doesn't work. Alright, let's just do vector 2 u mouse position x, and then this thing. Yeah, super confusing. Super confusing. Let's see. U mouse mouse position, and then this mouse UV dot y will be 1 minus this thing, and then we basically should have it. Right. Okay, this is acceptable. This is very much acceptable. What if we just add rid UV? Ah, perfect. Okay. So this is like that, and then we just have smooth step. Right, here. Right, so smooth step will be this. Let's just look at the reference. So yeah, edge, that's why it's kind of strange. So we want the edge to be in between, like distance. I mean, let's say the edge will be in between 0 and 0.1. And then this will give the thickness of the thing, which I would this is percentage of the screen, so just have it be 10% of the screen. Yeah, and we can draw this. I think, no, actually, yeah, I think that's fine. Let's just get some smaller percentage, and this could be even lower on the feathering. And this here will be 0. Okay. So now we have a point that follows our mouse. So unnecessary, but it doesn't matter. So here we basically want to add the D, and then basically have like a clamp D in between 0 and 1. And that will give us actually additive blending. So why am I using this is now, wow, I know what the problem is. Right, that is the additive blending we have. And we can disrupt the little thing that produces these curls. We want to have something that will just basically work. Something like this, I don't think will produce patterns out of nothing. Yeah, okay. Hell yeah. Okay. Now we have these like, yeah, I don't know, extending patterns. They extend like this, which is easy to see because basically this kernel is the transpose of the actual image. So we'll just get these very cool kind of picking up. That's cool. That's cool. I like this. Let's actually bump up the resolution of this. The way I want to bump up the resolution will be basically 256 of these. Right. Right. And that is the thing. Like, we're dispersing some stuff over the whole thing. Yeah. I mean, it's a crude drawing system, but it could work. So, right. Okay. Let's try some other stuff. So we had the thing, this function. We had this function do its thing, and we probably want to continue doing something in the same kind of way. Maybe flipping this will be interesting. So let's actually try just flipping this, where only stuff in the that is strange. Yeah, we want something that's 0 at 0. How about we get the sigmoid function? Yeah, how about we get sigmoid? Right, but yeah, I mean the logistic curve will, like, it will be something super close to this. Okay, let's just go book of shaders. There it is, book of shaders. Oh my god. So shaping functions first. Yeah, we can just smooth step. Fair enough. We can do something with sines and cosines. How about the following? How about we just get the absolute of the sine? Let's do that. abs sine x. This will be some oscillating function, which will be interesting to see. It's interesting how yeah, it's interesting how like this is actually what was full of my screen buffer. Right, this is the text. I have actually no idea. That's so cool. Yeah, that is so cool. What will happen if I just display this? Yeah, just let me just do this. We'll just have the we'll just have the thing. Yeah. Yeah, look at that. That's cool. And it's cool, I'm not gonna lie, but it's kind of strange that it happens. Even though it does make sense. Just want to reset this buffer for a bit. Yeah, so this will be this. So let's see. If u time more than 0.1, then it's this. Otherwise, it's just 0. We need a ternary statement here. Bam. Okay. And now we're creating the little kernels. Okay, that is cool. That is cool. And we're back to the previous activation function. So let's actually try and do sine x. Yeah, it will be abs sine x. Maybe even like times pi, something like that. So yeah, I mean, we can also like have something like clamp this in between -1 and 1. All right, let's try that. Sine this times, I believe I have this. Yeah, okay. Times pi, and then we want to clamp this in between minus pi and pi. Ba-bam. Great. I forgot this. Right. Damn, that is an interesting thing. Yeah, isn't that cool? Yeah, that leaves like these trails in the thing. That's nice. But also it's too persistent, and I kind of want it to flow in more directions. So maybe let's do something like this. Now this will flow like predominantly up and down. That's cool. Yeah, and it's just basically like almost glitching. But nevertheless, I kind of wanna do this again. Okay, that's kind of cool. Looks like an oil splatter almost. What happens when it connects? Oh, that's actually cool. Well, we can just smear this. Yeah, we can just erase these. That's cool. Okay, something else I want to try with these before we actually close the stream, because we're nearing the end. But basically, think of it in this way. So I want to do something that is with movement. So I think something like this makes sense. I mean, at this point, it's just like noise mostly. Let's actually do something like a swirl around the thing. So this will be 0.1, 0.2, 0.2, 0.3, 0.4, 0.5, 6, 0.7. Ah, that's cool. That basically like forms different lattice structures, and you can like destroy the boundaries basically. That's cool. I like that. That's nice. Um, what else? What else can we do? It's not that interesting. You know, it's not that interesting. Like you can kind of predict like what the behavior of this will be when you just do it. And most of the times it just results in this overly zealous noise, I think. Yeah, for me, like it needs to, like that self interaction should be there. right? This probably is not like that interesting of a function. Let's do something like smooth step. So smooth step, and we'll just do x, and then 1, 0, and 1. That's it. That is triggering epilepsy for some people, probably. Let's just remove the minuses. I just realized. Oh wow, okay. I'm guessing like this will be something. Oh, nope. Nope. Nope, nope, nope. This is actually painful to my eyes. Yeah, this is kind of painful. Yeah, that's nice. There's kind of something blowing in the wind. It's kind of cool. Yeah, it just gets blurred. But kind of like in this more swirly way. Let's explore something that is more interesting. Maybe something like a Bezier curve could be interesting. Yeah, okay, so we want to basically have something like yeah, how about we smooth step this from 0 to 1? Yeah, how about we smooth step it from, yeah, like something like this. Right, okay, so now we're smooth stepping from 0 to 1. We want to have the minus in some strategic places, I'm guessing. Let's try this. That's super interesting. It just becomes stable. Yeah, that is cool. That is cool. I don't know. Let's try and do like a Gaussian blur with this. Right. Let's see. Yeah, okay. The smooth step does not necessarily work particularly well. What I want to do is have this and that these nope. Let's end on something like a sine absolute of x. No, it will be absolute of the sine of clamp x between -1, 1, and then times 0.5 times pi. Something like this. So this will basically like have the same effect as yeah, it's just expanding, which I don't necessarily particularly adore, to be honest. Let's just do minus 0.5. I think that's more interesting. Let's just do cosine. That is super nice. Okay. Cosine here. Minus 0.5. Alright. Right, we want something that wouldn't transform 0. What was sine doing again? Yeah, this is this crazy broken function. The blue one. Yeah, this is this crazy broken function from here to here. Let's see how that goes. Yeah, the thing I want is just annihilation of things that are close together. Like something like this. Don't want the convolutional automaton to stagnate. That is cool. They're making like rocks and stuff. Yeah, just expanding, but also flying down. That is such a cool animation though. It's cool. Okay, let's see. So we got a function that is not that bad. Yeah, like not that bad at all. We can actually implement like a Bezier curve. Okay, I have that implemented somewhere, so I'm just gonna rope it from there. So this will be my graphics course. Splines. I think it was this, and then can you just type in work, please? Great. Right, I just want to have this basically. Right. Let's just get this in terms of some points. So the first one will be 0, 0. Yeah, the first one will be right, and this one will be 1, 1. Right, and now we want something like so we want the spline to look like, basically we want the spline to look like where's the spline draw? Is it this one? Yeah, we want the spline to look like this, basically. I don't know, something like that. You get it? Maybe. I don't know. So first spline, or like first point, will be at 1, let's say like 1.5, 1.51. Right. I think that will be reasonable. And this will be 75 at 0. Yeah, so we get these like super extreme peaks. And we can just do eval Bezier x. Clamp x between 0 and 1. Yeah, I don't need the position. Don't need this. I don't need this, and I don't need this. Ba-bam. One more thing that we missed was a bracket, and we still have stuff going wrong. Wrong time vector 2 in function activation. Oh right, we only need the y. That is kind of interesting. That is an interesting activation function. Yeah, very interesting activation function. Okay, now we want this kernel to actually we want this kernel to actually be kind of interesting. So let's do this. Yeah, and this will add some entropy to the mix. This will disappear. So now we have this strange Gaussian blur that actually should be cool. Yeah, let's just do -2, something like that. Yeah, this will be like very acid trippy, but like basically that curve is now super pulled up and down. And yeah, that is cool. I'll just do -2, 2 and -1. So like not as pronounced of an effect, but still there. The waviness is still here. But we want it to kind of dissipate through time. So instead of just this being the like only the Gaussian blur, it's just this will be stronger. But yeah, like instead of this being like a proper Gaussian blur, let's give it something like a very strong decay. Yeah, and I'll just shoot decay. Actually, it does not. Okay. I maybe am not understanding how things decay in that system. Yeah, that does not decay to time. Right. Which is a little bit strange to me. This is a little bit strange. So, yeah, if it's some constant, right, this will be the case. So we have activation of the sum, and then this is the thing that will pop out on the other side. Let's do activation functions. Yes. The sigmoid we tried. Linear. Yeah, we have like rectified linears and everything like that. We can get the hyperbolic tangent. Yeah, let's try the hyperbolic tangent. Maybe that will be interesting. Even though I think I think this is yeah. Okay. Unfortunately, this thing does not want to work properly. So I'm just gonna give some negative values. that is a nice spread that this has. Yeah, it's about spreading. So let's just turn this into minus 0.2, right? Spread like a wave. Yeah, these constant strobing lights kind of vibe creates this map, which kind of looks like a map on its own, like some kind of noise, and I don't know exactly why that is the case. All these I'm gonna turn to zeros. How about that? Yeah, this just dies out. And I want to promote having more of itself. Look at that. That actually looks sick. It is an interesting kernel idea, even though I kind of want to have the minuses like these. So now they will like spread in these kind of lanes. Yeah, it will be interesting to see bigger kernels, but that will be later down the line with the series, because we can basically make like more coherent structures with better kernels. Yeah, which will be just this one and this one, let's say. Then we get these things. Just cool. Like, this is just cool. Yeah. Yeah, those are some very nice sand plus filling stuff in. What is extremely great is that it like actually makes channels through itself. Yeah, Yeah, look at that. I like that. I like that it just like channels until it has nowhere to channel more towards. I like this one. This one, I would say is one of my favorite. Look at that. Yeah, it repairs the paths, like some of the paths that it has created. And like, if, I don't know, if I start a new movement here, that is so cool. Yeah, but the same thing will extend stuff up and down. I think this one is the best one we've created. Like, it creates all these channels that can then be modified, and all of these changes like persist in both directions, which is super cool. And also, it's kind of this like off-kilter presentation. Like, yeah, I don't know. I have no idea how to otherwise create something that is this cool. Yeah. Okay. What else can we do to improve this? Let's actually just do something like bias it on one side. Yep. That is cool on so many levels. So now reach this. Yeah, it's all these channels being dug through the thing. It's so cool to watch these just work. Especially the fact that these have like some boundary conditions that are interesting. Yeah, look, it's like rebuilding itself around stuff that it wants to rebuild. Yeah, that is so cool. Okay, I think to close the stream off, because we've been streaming for 2 hours and 45, let's actually try and make this thing a little bit more colorful by just basically making everything a vector 3 instead of that thing. Right, so I think I won't make the kernel bigger, but what I'll do is basically, let's actually check the specification. GLSL array. Do we even have that? Data types? Arrays. I was just searching for the what the fuck? Yeah, but how do I... When array indexing, OpenGL array version. Yeah, I need to see. Yeah. Oh. So this should have arrays. That could be nice. We can define the we can define like a changing kernel maybe in Rust, and then like pass that data to the GPU. I mean, it's quite a lot of data, but also I kind of don't want to. Yeah, I kind of want to be able to like click buttons and then have that change. Okay. Let's try and do something. So vector 3. Let's actually save this. Conv b and frag. And this thing now will be actually a vector 3. Cool. And will be XYZ or RGB, right? And then this activation right, then D needs to be vector 3. Let's do a float stencil. It will be stencil. Stencil. Yeah, it will be D plus equal to stencil, and then it should be B. I think that's fine to have here. Right. Should be vector 3. Ba-bam. Ba-bam. This will be vector 3. So let's actually use the same kernel, but multiple of the functions we tried. So one of them will be, for example, absolute sign clamp x in between -1, 1. Yeah, I think that will be like -1 and 1. What else? Right, and that will be times pi, let's say. Right, and then I want something more lively. Let's just do like x times 40, but like a frac. The fraction of this, or the fractional part of this. and then we'll just cargo run, create a backtracer. I will close this. Okay, let's see. So eval Bezier. Right, XX, XY, XZ. Must be matching types. This will be vector 3, 0. Boom. Okay, that will be vector 3 error stencil. What? How was that undeclared? Initializer for type float cannot be assigned to a variable of vector 3. $48. Right. This will be vector 3. This 59. How is that undeclared? I have no idea. Stencil? Oh my god. Yeah, and you can see how that is developing basically. That is super cool. Yeah. I mean, you know, like it's okay. It's okay. Let's just do Y, Z, X like this. Yeah, this is something that is completely like extremely interesting, but also just noise. It's just noise. Let's extract these outside of this. So we just vector 2 A, vector 2 B, vector 2 C, vector 2 D. Right, then all of these will be a little shaky, but still Right. Just think this would be this would be fun to have. Right, these are A, B, and C. A, B, C, B. Right. And then these. Yep. Let's just shuffle some shit around and get it to work with more or less the same function. This will be just this. Yeah, I think it will be nice to see actually. So now it's a different Bezier. I don't mind just doing this. Yeah. Alright, so the float is here, and then compilation error on 31. 31. Alright. Comma here, comma here. Babam. Compilation error on 48. Interesting. Unexpected. Why is it unexpected? Is it because of this? Yes. Right, it's about just like having less aggressive thing. It's doing the same kernel in different ways. Right, I mean, that's probably too subtle. That's probably too subtle. Let's just do n minus 4. It would be more cool if this is Z, so they just exchange values. Yeah, and you can see how they're just like glitching about, doing different stuff. Yeah, that's nice. They're just rotating around, mixing all of the functions and how they grow. Yeah, to be honest, like I think having W here as well will be cooler. This is super cool in terms of like the how the fringes are doing. Yeah, do some more stuff here. Hello, hello. But yeah, thank you. Yeah, basically it was using the same activation function, and here we're cycling the colors. So every time we're taking a different color channel and mapping it through the function, and then this grows and shrinks depending on which direction you look at it. And yeah, that's pretty much it, to be honest. Yeah. That's why you get like these artifacts where the functions are disagreeing how the automaton should behave, and those are the blinking segments. Basically, like here, for example. Here there are like multiple different channels being carved in different automata functions, and then we just cycle through them. And that's it. Okay, I think that will be it. I'll definitely be on top of this, because thank you. I even didn't actually drink the tea, so I'm just gonna take a sip to close the stream properly. Cozy, eh? Cheers, cheers. But yeah, exactly. I'll be back on this. Maybe in the future we're gonna do like bigger kernels for the automata, but I am completely surprised like how you know how good this can turn out with just 9 values. Yeah, I think that's pretty much it for the stream. Thank you for watching. Thank you for everybody that joined in. Thank you to the voices within and stuff like that. Okay, see ya. And this I'll upload to the GitHub. I'll commit it right now. So this code is publicly available. You can make millions off of it and yada yada. So yeah, see ya.